So 1-7 is modeling. So we're going to use all these ideas. And we're going to kind of meld stuff together. We're going to use our calculator a lot. But the first thing we're going to do is we're going to practice just changing functions. We're going to make functions work for us. And that's what this class is really good at doing. We're like, okay, you know what? I have this thing, but I don't have any of that information. So I'm going to make it so I can use something and keep going. I'm not going to stop. So what we're doing here is just literal equations, and we're going to use some substitution. So can you write the area as a function of the radius? How would you write that? Area equals pi r squared. That's area as a function of its radius. So now the next one, they say, okay, that's great. But what if I wanted to know the area as a function of the diameter? So what I got to do now is I got to relate the radius to the diameter first. So what do I know diameter is equal to? 2 times the radius. But I want to be able to replace the radius. So can I solve this for r?
Yep.
Divide by 2. So radius equals diameter over 2. So now I can use this with my area equation. So area is going to equal pi times diameter over 2 squared. And we're going to simplify this a little. Are you okay with that substitution?
Mm-hmm.
So what's d over 2 squared? D squared over 4. And I'm going to, can you think of this as, because it's like over 1, so multiply, right? So that'd be pi d squared over 4. And can I think of it like this? Would I be fine if you stopped here?
Yes.
Yes. I want us to go there because I know what we're going to do next. So, next thing we're going to do is relate it to circumference. So what do you know about circumference in relation with the diameter? So circumference is what with the diameter? Circumference is, if you don't know it, you better start looking it up. Circumference of a circle with the diameter. Pi d, diameter times pi. Mr. Showalter, you saved them. So, how am I going to be able to get this so I can get rid of the d and use the circumference instead? I need to get rid of the d. So can I use this to help me get rid of the d? I don't want r, I want circumference in there. Divided by pi. So diameter equals c over pi. Now can I write area as a function of circumference? So area equals pi over 4 times c over pi squared. Now if you cancel your pi's without doing the square first, that is a big no-no. Don't do it. It is illegal. No, no, no. We got to square it first. So what's c over pi squared?
C squared.
C squared over.
Over pi squared. Now we can cancel, because this pi is going to cancel and leave 1 on the bottom, right? So you have c squared over 4 pi. This was all just about pure manipulation. Just showing that you can substitute stuff for whatever we need. Okay? And also makes us remember our geometry formulas.
So an area of a circle is circumference squared divided by 4 pi.
That's one way to look at it. Not the most handy way, but it's one of the ways. Is that okay? The next question is a box with no top. Oh, we've seen these before, and I told you we'd see them again, and sure enough, here we are.
Do you want me to make more coffee?
Please.
Okay.
Thank
Enjoy. Learn. Lots. What are you learning?
Box with no
Box with
top.
The box with no top?
Yeah.
Yeah, we do that one too.
In calculus. They do it again. And don't worry, she knows how many times we do it in here.
Did it
Yeah,
ever go away?
it's mostly in here. You guys do it a lot, but we do it when we're doing calculus with maximums and minimums. Maximum volume, minimum surface area. Learn this.
It's important. Okay, so we have an 8-inch by 15-inch piece of cardboard. We're cutting X by X squares out of the corners. And then we're folding it up and making a box with no top. Stop, please. Is this okay? So, if I cut X by X squares, what's the height of the box? X. And if this whole length is 8, but I cut X inches from this side and X inches from this side, 8 minus 2X. And the same thing here. If this is 15 inches and I cut X from here and X from here, 15 minus 2X. And they want to know what the equation of the volume. So how do you find the volume of a rectangular solid? What? Perfect. You multiply all the dimensions together. Please don't FOIL it out. Just let it be.
Really want it.
I know. Sorry. I don't want to. If you can't, you can if you really want to, but I would just let it be. Because you could make a goof. Don't make a goof. Are you okay with the volume equation? Do you see where it came from? Okay. We need to find the domain of our x's. So what's the biggest and what's the smallest size square we could cut? What's the smallest size square we could cut? 0. We wouldn't, but we could say, I don't want to cut my cardboard. So we could say, I'm not cutting it. Or, now remember, we got to cut the same amount from each side. What's the biggest size we can take? 4. Why 4? It's half of the smallest side. So, would we really cut 4 from each side? We wouldn't have anything to fold up. Not likely to happen, but could we if we so chose? We could. We probably wouldn't, but we could. So the maximum size we can cut is half of the smallest side. Because if it was 8 inches and I had to cut 6 inches from both sides, does that work? No, I'm cutting into itself and we're like in the parallel dimensional universe and it doesn't make sense. It makes my brain hurt. Okay, so half of the smallest side is our maximum. Now we're going to graph it. Why am I the only person that went for a calculator? There we go. There we go. So the equation was x and then 15 minus 2x and 8 minus 2x. Are we good? Okay there? And then we're gonna go to our we're gonna go to our window. And our smallest x value was 0, and our biggest for our domain was 4. What do we want our y max to be?
20.
Now, I think we're talking about volume. What'd you say?
500.
Okay, we'll be crazy. We'll try. We'll see what happens. You ready? That might have been a little big. It's going to be hard to find that maximum because it's really flat up there. So I would bring this down a little bit. Let's try 250. That's better. You get more of a peak. You see what I mean? It's less flat spot at the top to have to worry about. It's a little more peakish. So can we find that maximum?
Yes.
So second, calculate number 4. So for the maximum volume, I got 90.74 cubic inches. And what X gave us the maximum volume? 1.667 inches. Yes? So for part C, they said graph it. Okay, what's the max volume? 90 this cubic inches. And how big should we cut the square to get that max volume? That's how big the square was. Or should be. It's basically 1 2/3 square. Are we okay with this one? We've done this kind before, yes? Yes. We'll do it again. Don't worry. You can tell William is really upset about it. Not really. I'll just try to make you smile a little. Okay. We have grain that is leaking through a hole in a storage bin. Sad day. This is in 8 cubic inches per minute. That's going to be important. The grain forms a cone-shaped pile. Now, when they tell us cubic inches, what unit of measure are we talking about? Volume. This is volume. Okay? And then they tell me I have a cone shape. So if they give me the volume it's increasing per minute, what do I think I need to find out for this cone? The volume. How do we find the volume of a cone? Multiplied by a third, not divided by. Good. So the volume is 1/3. What is the base in a cone? Pi r squared times the height. You remember this from geometry. When you guys find volumes, it was area of the base times the height. Area of the base times the height. But a cone is 1/3. So it's 1/3 times area of the base times the height. So he saved you from having to look it up. What happens if you get home and you can't remember?
Google. Call Karen.
Look it up.
No,
Google
do not
that
call
thing.
Karen.
Google it.
I can just walk over to Miss Carlick's house.
She might be a little bit crabby.
She always leaves her door open. I always find that weird.
I'm really glad you just told that when I'm recording. Awesome. Now I have to check to make sure we can't hear that. Oh,
He didn't say the
you guys are killing me. You're done. I'm done with this conversation. Okay. As it grows, I know. Lame. Ugh. The height of the cone always remains equal to the radius. So what do we know about R and H then?
They're always the same.
R equals H. Okay. Right here, the cone is 1 foot tall now. How tall will it be? So do I want my equation to have radius in it, or do I want my equation to have the height in it? The height. So, but we know that they're the same, so could I have my equation as 1/3 pi h cubed? Do you see what I did?
No.
The radius is equal to the height.
Oh, yeah.
So this would be height squared, but we have to multiply another height, so it's height cubed. Is that okay?
Yeah.
All right. So we know that it is how tall is it right now? 1 foot. So can we figure out the initial volume of the cone?
Mm-hmm.
So initial volume. 1/3 pi. And we know what the height is. but be careful. They told us it's 1 foot. But what other unit of measure do we have to worry about? Inches. They told us it's growing 8 cubic inches per minute. So its height is 1 foot, but how many inches is that? So can we figure out the initial volume of our cone? So we gotta go 12 cubed.
You want to use 3.14 for pi? Or?
No. We're gonna leave pi in our answer. I think it's 1728. And what's a third of 1728?
576.
So that's the initial volume. Right when we walk in the door, we're like, oh, no, not the cone-shaped pile. That's how much grain is in the cone-shaped pile. And then we're like, oh, now it's great. It's growing 8 cubic inches per minute. It's craziness. And we want to figure out how much it's going to be in 1 hour. So we start with this many cubic inches. Can we figure out how much more we gain? It's 8 cubic inches a minute. So how many more cubic inches do we gain in an hour?
480.
How did you get 480?
8 cubic inches times.
How many minutes? So it's 8 cubic inches a minute, and we looked at it over 60 minutes. So 8 times 60,
480.
480. So this is how much we started with, and we added 480. That is now the current volume of grain in our cone-shaped pile. What's the question asking? How tall is it? So we want to know, when does that, here's our volume, we want to know when it equals our volume equation. We got to solve for H. Not yet. That is the last, we're undoing the order of operations. Exponent is one of the last things we're going to deal with.
That's annoying.
Times by 3! And that means I gotta times this side also by... Okay, don't do that, please.
Like that was.
Okay. And I'm not actually gonna multiply it out. I'm just gonna leave it like that. Otherwise the numbers are really big and then I gotta run out of space and just a hot mess. Now, why am I not putting 576 pi and 480 together?
Because 576 has pi attached to it.
Okay, the 576 has the pi, so it makes it so I can't put those two things together. Now what do we need to move away from the H? So we have 3 and then this. Now, why am I not canceling the pi out?
This is attached to the 576.
What if the 480 had a pi? Could I then cancel it? Yes, I could. But does the 480 have one? No, so I can't, so don't. Now we gotta undo the cube. Now I heard somebody say cube root. But here's the thing I get. I don't know where the cube root button is in my calculator. And what if I told you to do the 7th root of it? I don't know how to do that on my calculator. Okay, great. Whatevs. Can you write one cube root as a rational exponent?
You could also go to math 4 and 5.
Okay. You're going to raise it to the 1/3 power. The cube root is the same as the 1/3 power. Because I can do that every time on my calculator. Okay?
Would it be wrong if we did the cube root?
Huh?
Would you count it wrong if we did cube root?
No, if you got the right answer. I just want you to understand, because every time, I don't know where this is in my you don't need to know where it is. You need to know how to change it to a rational. Then you don't have to worry about it. Done. Solved. Problem solved. So, now when we put this in our calculator, we got some parenthesis fun we're going to have to deal with here, okay? So, I need this big parentheses around the whole thing. So I need a parenthesis. And because we're talking about a fraction, I also need a set of parentheses around the numerator, yes? So I need a parentheses right here as well. So I'm going to have parentheses 3. What comes after the 3? Parentheses 576 pi plus 480 close that parenthesis, close the top, divide by pi, close the old. Huh? No, because it's just one number. If it was multiple things with a plus or minus, yes, I would. Even if it didn't have a plus or minus, actually, if it was like 5 pi, I would have to also put parentheses around the denominator. But because it's not, I don't have to.
And then up to the 1/3 power.
Then caret, parenthesis 1/3.
Fun. That was awesome.
How tall is the grain pile?
13.
Almost. It's 12.98. In an hour, it almost grew an inch in height and in radius because they're the same.
Wait,
You almost grow a foot.
An inch.
That's 12 inches though.
It started out a foot tall.
oh,
In an hour, it grew almost an inch in radius and height.
wait, yes.
Okay, that was a hard question. I know it's kind of a hard question. It was kind of fun though. We got to talk about grain piles. I mean, how often do you talk about grain piles? I don't know. Not very
When I
often.
talk with Barry. Every time I talk to Barry.
Oh, you
Okay. You may have done this quite a bit in science when you convert units. We like change feet to second to miles per hour versus vice versa. What we're going to talk about in here, we're going to talk about we need to change things to rotations per a unit of time. Now, we're talking about a tire. So what shape is a tire?
A circle.
It's a circle. The last time I checked, it was a circle. Now, a circle. That's my sketch. Beautiful, right? If I started here and I went one rotation around my circle, how far did I travel?
360.
I didn't ask you in degrees.
The one.
Not for what do we call a circumference of a circle. So one rotation of a tire is the same as the circumference of the circle. Okay, that is key to finishing this problem. One rotation of a tire is the same as the length around it, which is the circumference of said tire. Nothing? Oh, okay. All right.
Why do you always say said tire? Like said.
Just let it go, man.
It's an English thing.
So rotations, and they give me this in it. So can I figure out what the circumference is right now? Because I saw rotation, so I'm like, I bet you I need circumference. So what's the circumference if the radius is 15? Circumference of a circle. So 30 pi inches. Yes. Now, I'm going to use that little nugget of information last, but I'm going to need it. So, they tell me we're traveling 70 miles per hour. And we want to get to rotations per second. That's my goal. Have you guys seen this in science before? Where you cancel out units? Physics a lot. You do this a lot in that class. So can we get from hours to seconds? So what we're going to do is we're going to multiply this by 1 hour is the same as 60 minutes. And if you know the whole straight over, you can do it. But right now I'm just going to do this. Because really 1 hour divided by 60 minutes, is that really the same length of time? Yes. So really I'm multiplying it by 1. I'm just changing the unit. So now the hours are going to cancel out. So now we're left with miles per minute. But I want per second. So 1 minute is the same as
60 seconds.
60 seconds. So those are going to cancel. So I'm now miles per second. Is that okay to there? And I need to get from miles to rotations. But I know one rotation is this many inches. So how can I go from miles to inches? 80 what? Feet. So we're going to go from miles to feet feet to inches, inches to rotation. Oh my, so much fun. We're gonna write it down. Don't worry. So, 1 mile is the same as 5,280 feet. And I know that 1 foot is the same as 12 inches. So thus far we're into inches, but I need to get to rotations. So I know 1 rotation is the same as the
30 pi.
the circumference, 30 pi inches. So all I'm left with on the top for units is rotation. All I have left on the bottom is seconds. And now we're just going to multiply and divide. Are you guys okay with the conversions? The trickiest part is the 1 rotation is the same as the circumference. And you may not know this, but can you look that up? How many feet are in a mile?
Yes.
Yeah. If you don't remember it, and that's okay, I'm not asking you to. Just know where to go. If you have your planner still, then know that stuff's in your planner.
4.12.
So, I don't remember. That doesn't sound right
Wait,
though.
why'd you put pi
4.11.
or pi in? Oh,
Because the
I see.
circumference of a circle. Is that okay?
Remember.
So on the top, we have 70 times, what else are we multiplying up on the top?
5,280.
Times, oopsies. That's the top. We're dividing it by 60 times 60 times
30 pi.
30 pi. So the stuff on the top is in parentheses, the stuff on the bottom is in parentheses.
4.11.
4?
I got 13, yeah, I got
It's 5,280. You forgot the 0. So you should get like 13.07 rotations a second. Think about it. When you're going 70 miles an hour, think about your tire. In 1 second, it has made 13 complete rotations. Boggling of the mind. Right? I think so. Crazy. That would be that many rotations a minute. That's a lot of movement on that tire.
This one is getting a weird one.
Is that okay? I love conversions. It's so much fun. Okay. Now this last one, I need you to get to page 144. And we're going to put some stuff in our table. So in our stat list. And I screwed up earlier, so I got to redo it. And if you look here, the Y is the high temperature and the X is the low temperature. So that means list 1 needs to be your X's and list 2 has to be your Y's. So your low temperature goes in here and your high temperature goes right here.
We've got this other-
Oh my gosh, you're awesome. It didn't came fast.
I know.
I think you mean that's for me.
I
Thank-
know. It actually came in like 2 days ago, and it's just been sitting in my foyer.
Thank you. I'm
See,
so
I'm sitting behind
excited.
the desk, so that should belong to me.
Hmm?
I said I'm sitting behind the desk. So
Show the camera. I got some bags. They're pretty. I'll show you later. Bags.
Can I look at your
I'll show you. I'll show you. But we got to do this first. We got to finish this.
Can I see your calculations after this? Keep getting the wrong number.
Yeah, I'll look at your calculator when we're done. So, on page 144, this go low. Both of the columns need to go into list 1. Both of your highs need to go in list 2. I don't hear any clicky clacky at calculator, so I know you're not doing it yet. And I know fake calculator clicking when I hear it. And I gotta check mine because I screwed up somewhere.
You can't make fake calculators. You can just notice it.
Oh, there's where it's. Nope, that's right.
Ooh, they're gonna do testing graphics. gonna be watching this video, so it's gonna be a couple minutes of
That's fine. Giving them time to do it. So did you guys get your things in list 1 and list 2? What we're gonna do is we're gonna graph them, and we're gonna have our calculator tell us something called a regression line. There's lots of different types of regression lines, and here's a whole page of different types of regression lines. There's linear, there's quadratic, there's cubic, there's quartic, etc., etc. And for all of you people like, I don't know when I'd ever use this. Over here they tell you when would you ever use this? For a quartic, if a cubic didn't fit good, why would you use a cubic? Volume as a function, cubic growth, logarithmic, Richter scale, sound decibels, inverse exponentials. But they give them to you. Kepler's third law, for those of you who are in physics.
Never.
Inverse squares.
Well, they didn't teach us well, they don't, in physics, they don't teach you modern physics. They don't teach you anything after like the 1800s.
You take this?
I took physics last year.
Well, if you go to college and take physics, you'll learn new stuff.
Yeah, I was in physics last year.
So, regression lines. So you got to know what the general shape is. So, you got your stuff in your list, yes? We need to graph it. So how do we get to where we can graph this? Second, y equals, that's our stat plot, yeah? Turn it on. And I put stuff in list 1, list 2, so this should say list 1, list 2, which it does. And before I graph, I want to go to my y equals, and I need to clear my equation. And I need to fix my window. So let's go to window. What was our smallest low temperature? 52? 50. I see a 50. So what should our low be over here? 45 is good. What's our highest low temperature? I found there's an 82. 82. So what do you want to put our high at? 90, 85 or 90, your choice. I don't care. What was our lowest high temperature? See a 68. I think it's 68. So I want to go to 60. And what's our highest temperature? 106? 110, 115, your choice. And then we're going to look at it. So you have to decide what kind of regression. Does that look linear, quadratic, or cubic?
Oh, Bob.
It totally looks like linear, right? Yes?
Mm-hmm.
It's definitely not a quadratic shape. Of all the shapes that we have to choose from, it looks more linear. I would like us to do one more thing on our calculator because I haven't had all of you in Algebra 2. If you had me for Algebra 2, I already had you do this. But I need you to hit second and 0. And it brings you to something called the catalog. Yes? And if you look right, this little A up here in the corner means it's on alpha lock, which means so my alpha button in my case is green. So any button I hit is going to go for the green part of it, yes? I want to jump down to the D's. I don't want to scroll all the way to D. I just don't want to. I have better things to do with my time. So if you find the green D and you hit that button, it'll jump you straight down to the D's. And I need us to find diagnostic on. There's 2 of them. There's diagnostic off and there's diagnostic on. I want the on. So when you find it, hit enter and it'll jump you to your home screen. And you have to hit enter again. And it should say done. Does it say done? Done. Okay. Now we can go ahead and do our linear regression. Clear my... So, to get to the regressions, if you hit stat and go over to calculate, these are where the regressions live. And we said ours look linear, right? So ours is going to be linreg. Linear regression. So number 4. Now it automatically uses list 1 and list 2. If you were in different lists, you would actually have to go second 1, comma, second 2. So that's saying list 1, list 2. But ours are already in there, so do you have to do that? No. I also want to graph the regression line, and I can make it graph for me. So, I'm going to delete. Okay, so here's what you guys are looking at, yes? Does our screens look the same?
No.
Some of you guys have a little bit different. I'll have to help you in a second. I want this to graph for me. I want it to put into Y1 for me. So if you hit vars,
How you get there?
where?
That menu.
This?
Yeah.
I hit the stat,
Okay.
calculate, linreg. So if you hit vars, go to Y vars. What mode are we in?
Function.
Function mode, and I want to put it into Y1. All I did was tell it to put that equation into Y1. Is that okay?
Mm-hmm.
And hit enter. And all this magic happens.
Wait. Bars, then go to Y bars. and push function.
That's a big number.
So, these are our equations, yes? So our A is our slope, our B is our y-intercept, and now these R values. These are what the diagnostic turned on. The closer your R value is to -1 or +1, the better the fit. If your R value is close to 0, that is not a good fit. You pick the wrong regression, or it doesn't mean anything. It's just a random smattering of points. So our R value, is it pretty close to 1? Yeah, so is it a pretty good fit? It's pretty good. So do we have our equation? So our equation is y equals 0.97x plus 23. And I got that from my calculator. Do you guys see where I got those numbers from? And they want to know what's the high temperature if the low was 46. So what are we going to do with that 46? Put it in for x. Now, here's the nice thing. Because I made the equation go into Y1, I can go second table and just type 46. I don't have to do it by hand. Is that okay? Okay. So your high temperature would have been 67.63 degrees. All right. There it is. If you had a calculator issue with the regression line,